Uh, Still have a few people trickling in. I'm going to give it another 30 seconds, maybe another minute, and then we can get started. All right, well, let's get going with this. Okay, welcome to Cambridge Isotope Laboratory's third installment of Isotope Days 2025, featuring presentations in the scope of environmental analysis. I'm Ben Priest. I'm the business manager for the environmental product line at CIL, and I'll be moderating today's presentations. Today is the final chapter of our 3 Isotope Days sessions, following the excellent presentations on mass spectrometry and NMR applications. For more information or to view those presentations, please visit our website at isotope.com. And we will also have a QR code link to the Isotope Days landing page on our website at the end of today's webinar. I'm very excited about today's program. We have an excellent group of scientists who will be sharing some incredible work in a variety of topics. The content is diverse, featuring cutting-edge applications using stable isotope labeled standards. We appreciate all of you for joining us today to share in the information presented by our speakers. Our goals for today's webinar are to share information from leading scientists about recent analytical developments utilizing stable isotope labeled standards, to encourage further discussions in these application fields, keeping researchers informed about CIL's range of isotope labeled products, and also to generally promote engagement in these worldwide research topics. Our program for today's Environmental Analysis Isotope Days webinar includes some exceptional scientists speaking on subjects of current interest. We're very pleased to have presenters from 3 continents representing scientific work in Japan, Belgium, and the United States. Each of our speakers today will have 20 minutes allotted for presentations, and we will try to have approximately 5 minutes afterwards for a Q&A following each talk. The presentations will be recorded in case anyone would like to review them after today's webinar as well. We welcome discussion with the presenters, so please, if you have any questions, type them into the Q&A box along the way, and we will try to address each and every one of them following the talk. If we don't get to some today, we will deliver those to the speaker at the conclusion of the talk for later follow-up, and they can also type responses to you in the Q&A section as well. So look for those answers to be included if you have some. Before moving forward, I'd like to take a brief pause and ask that you complete the short general survey. There are just 3 questions in its multiple choice format. It will allow us to gain some insights into your research interests and applications. And here's the poll. We'll give this just another minute or so for you guys to log in and generate your answers. Okay, looks like we've got a good number of responses to that. Thank you very much for helping us out with that. All right, Chrissy, can you take down the poll? I think that's still up.
The poll is down, Ben.
Okay, sorry. All right, moving on. Our program for today's environmental analysis Isotope Days webinar includes some, oh, excuse me. Sorry about that. All right, so moving on. Our first presenter today is Dr. Shoji Nakayama. Dr. Nakayama holds both MD and PhD degrees. He is certified as a public health specialist supervisor by the Japan Board of Public Health and Social Medicine. He serves as associate editor of Environmental International, as well as the Journal of Exposure Science and Environmental Epidemiology. In 2005, Dr. Nakayama was invited by the U.S. Environmental Protection Agency and spent 6 years conducting exposure research on contaminants of emerging concern. In 2011, Dr. Nakayama joined the National Institute for Environmental Studies in Japan. Currently, he is Deputy Director of the Japan Environment and Children's Study Program Office. He also holds a professor title at the St. Luke's International University, the University of Tsukuba, and Icahn School of Medicine at Mount Sinai. Dr. Nakayama is a lead exposure scientist for the Japan Environment and Children's Study, JECS, which is a longitudinal birth cohort study involving 100,000 mothers and children. He is devoted to human biomonitoring research. Exposome research is his most recent activity. He collaborates with US, Canada, EU, and Asian researchers to advance and promote children's environmental health. I'd also like to point out that Dr. Nakayama is joining us live from Japan, where the time is currently just after 10 o'clock p.m. Thanks for joining us today, Dr. Nakayama. You can start your presentation now.
Thank you, Ben. Thank you for giving me such an opportunity to make a presentation here. Today I'm going to talk about our works on children's environmental health, on epidemiology and human biomonitoring program in Japan. I'll be mostly talking about like more towards the epidemiology and biomonitoring side than the actual analytical technology, but I'll introduce you how the reference standards and isotope standards will work in this type of field. So thanks to Ben, so he just introduced me, so I can skip this my introduction. But I spent 6 years with the U.S. Environmental Protection Agency, and I hope they survive in this difficult days. But that experience helped me a lot. And then without that, I won't be here. So then I took my position at NIES Japan. Since then, I've been doing this this kind of work. So I started my work at the US EPA in 2005, and here's my colleague at that time, Dr. Mark Schreiner. We went out to collect like environmental samples, and then we measured PFAS in it. That was the early time PFAS research in the world. And then I moved up to Cincinnati and worked for Mark Mills and the other other colleagues on the mostly the management in the risk management side of the emerging contaminants. And this is my early work. And here we have the North Carolina, so the EPA I first worked for was located in North Carolina. And then we went out to collect samples from the entire river basin that was close to our lab. And then we measured PFOA and PFOS at that time, and then found out some hot spots. So it was interesting that at some portion of the river that has a huge, drainage pipe. And then I just went there and then collected samples from there, and then we found huge concentration of PFOA. We found out later that was the drainage pipe from DuPont Fayetteville, plant. And then later on, Mark Schreiner just did a follow-up study and he found a new PFAS compound that was called like a Gen X, and in other words. Those are the very early time of the PFAS study in the US. We, obviously used isotope labeled standards for that. And then after that, we did the study of the catfish liver in the North Carolina, and we were on the news at the in the Minnesota state of Minnesota, and then some of the states, along with the Mississippi Upper Mississippi River basin, just asked us to measure their samples too. So we and collected all the samples. We collaborated with those states, Minnesota, Wisconsin, Iowa, and Illinois and Missouri. And then we collected samples from the upper Mississippi rivers and other rivers within the basin. And then we measured PFAS in the river samples and found many hotspots and then possibilities of the sources. And then I took my job at the NIES and I studied more towards the epidemiology side. So in 2011, Japan started the nationwide birth cohort study that involved more than 100,000 pregnant mothers, and then we and then follows up the children who were born to the mothers. Then, so they started that in 2011 and then started the recruitment and then they completed the recruitment in within 3 years time, and then they recruited over 103,000 mothers, and then we have been following the children up for the last 14 years. And it has been planned to follow the children up until they become 13 years, but we recently decided to extend the study up until they become like a 40 years or plus. And it consists of the main study of the 100,000 participants, all the participants, and as well as we formed the sub-cohort study. We selected 5,000 participants randomly from the main study. And then we performed the home visit and measured indoor and outdoor air quality and measured particulate matter. And then we collected health test. And also we are doing more extensive studies on the children, like the physical examination, blood and urine collection, every 2 years. And then so far, as I told you that we have over 103,000 mothers, and then we've been following over 100,000 kids. And then the oldest kid is now turned 14, and the youngest is now it's turning 12. And then we have many biological samples. I'll tell you later. And then also we have sub-cohort study. And here is the biospecimens, major biospecimens we collected from the participants. We collected blood and urine from mother and breast milk from the mother, and then cold blood samples at birth, and then also we collected hair samples from mother and child, and then we've been collecting blood and urine samples from children. And those are the chemicals we have measured in our samples so far. That includes like elements and then mercury, and nicotine metabolites, PFAS, organophosphate pesticides metabolites, environmental phenols, phthalates, neonicotinoid insecticides, and so on and so on. For most of them, we used isotope dilution methods. We try to use one-to-one isotope dilution for the most of the compounds, but some of them we couldn't find the specific isotope labeled compounds. But I would say almost 90% to 95% we have one-to-one matched the isotope dilution. And as I told you, we also have measured environmental samples. And then for the first 4 years, we haven't had zero. I mean, we haven't had any publications, and then we had so much pressure from our government. We're spending so much money on this study, but we are having nothing. Because we were doing the recruitment, we haven't had any results. But after that, we are having steady publications. Now the total number of publications exceeded 500. And I'll show you some of the results. For example, we measured neonicotinoids in the urine samples we collected during pregnancy, and we looked at their effects on developmental milestone. We didn't find any associations, but we were also looking at other effects of the neonicotinoids. We also took a look at PFAS, and here's the results for the PFAS and asthma. As you can see that we have negative effects. That means protective effects of PFAS on wheezing and asthma. For example, if PFOA had a protective effect on that. And then we've also looked at the effects of PFAS on Kawasaki disease. Kawasaki disease is very common in Asian countries, and then it's considered as some related to immune conditions. We found that negative is the similar trends as the asthma. We saw negative association between PFAS and Kawasaki disease. We don't know the reasons, but we speculate that they might be related to some immune responses. So PFAS had have some effects on the immune system, and then the asthma and also Kawasaki disease are thought to be an immune-related disease. So PFAS decrease the immune response, and that's the PFAS is related. It's in a scene to related to the decrease negative source as a relationship with those immune-related diseases. And we've also looked at organophosphate pesticides and both outcomes. We found a positive effect. That means the more the OP exposure, the longer the gestation age. We don't know the mechanism, so we need to look into the mechanism, but we've been finding those things. And then we also looked at environmental phenols, including bisphenols and nitrophenols and nonylphenols and octophenols in urine samples, maternal urine samples. Here I show some results. And bisphenol A and paranitrophenol were found more than half of the samples, even though the concentrations were very low. But we found some of the participants had very high concentration of the BPA or those bisphenols as well as nonylphenols. We don't know why, so we need to look into that. And also, we are looking into their effects on the children's health. So we looked at the effects of BPA on pregnancy outcomes. For example, preterm birth, gestational diabetes mellitus, low birth weight, and other outcomes related to pregnancy. We did not find any relationship between BPA and pregnancy outcome. The importance of this study is that because we have the large number of sample size, if we don't find the associations, it is very important that you know, so it is very likely that we don't see actual associations. We've been looking at the genetic information, but I'll skip this one there. So for the future, we'll be following our children up until they become 40 plus years. So now we are going towards to make up a come up with the protocols after 18 years. And we're also planning to make up a second cohort, which means we are going to recruit a new cohort of pregnant women because we recruited our participants almost 15 years ago. The environment has changed, so we're planning to form a new cohort. So we've been collaborating with other international cohort groups, and then we do need more collaboration because even though we have 100,000, we only have 20 to 30 ALL cases, childhood cancer cases. So we do need more numbers. And then I'll quickly tell you that we have started the nationwide human biomonitoring program finally in Japan. It's the first year of the cycle one. We are going to collect samples, blood, urine, and hair samples from the participants selected randomly all over Japan. And then I also, formed the international working group on human biomonitoring programs. This is to harmonize the health-based human biomonitoring guidance values as well as how we're going to perform the HBM program worldwide. So this work has just started and since the 2018, but we're having so many people joining in this working group so that we can extend this the collaboration on the human biomonitoring all over the world. And so this is the final slide of my presentation. So as all of you know that it is very important to keep the integrity of the reference standards for those kind of the works. And then it is also very important to have the cross-validation among different laboratories using the same reference standards. And I have some experience that I ordered some isotope labeled steroid compound, and then I found no peaks on it. And then I didn't get the NMR certification. And then since then, I will never use those kind of providers. So I've been with the CIL for the last more than 10 years. And so many of my friends have left the CIL, but still, Ben and then other very nice people at the CIL, and they are very trustworthy. And then we'll work with the CIL for the next, I don't know, 30, 40 years. So thank you for listening, and then I'll hand it over to the Ben for the questions. Oh, you're muted, I think, Ben.
My apologies, everybody. My audio was turned off for a moment there. So I was saying thank you very much, Dr. Nakayama. We really appreciate all of the work that goes into this session. You have a huge cohort and so many things that you're working on. It's really an incredible project. We do have time for a couple of quick questions if anybody wants to add in. The We do have one that came in. How do you get PFAS content of the sample using isotope PFAS standard? What is the general procedure? That sounds like a
Sorry,
pretty lengthy answer, but go ahead, Dr. Nakayama. Do you have an answer for that?
sorry. Can you repeat?
Yeah, it says, how do you get PFAS content of the sample using isotope PFAS standard? What is the general procedure?
Well, so that depends on the samples, um, environmental samples and biological samples are different. That's what the question means.
Yeah, I think what they're asking is basically the answer, I think, is using isotope dilution mass spectrometry. So you have to take your sample and extract the chemicals and go through the process of quantifying against a calibration curve or
Yeah,
you
right.
go.
We add the isotope, reference samples before we do any extractions and everything. So then we can track them, as well as and then also we use the isotopic different types of isotopic labeled stamps. For example, we use C, so how can I say? 8C, for example, C, 13 labeled PFOA for that purpose. And for example, 6 carbon labeled PFOA for the final stage, to account for the injections and the instrumental variations. So two different usage, but basically we add the stable isotope standards into the samples, and then do all the analytical works.
Very good, thank you. I had one other quick question for you as well. I was wondering if you found any compound classes that surprised you as far as occurrence or concentration levels, and especially if they had any other correlation effect or correlation to health effects, things that may have come up in your study so far that sort of surprised you.
Well, whatever compounds I'm in.
Yeah, any compound classes like the certain pesticides or PFAS or other things, the phenols that you found them more frequently than you might have expected or at higher levels than you might have expected, and how that affected any kind of results that you're looking at for them.
Yeah, well, because we didn't have the nationwide, biomonitoring study until now, we don't know how we're gonna expect. So that's one thing. But we've been measuring very old blood samples from 1990s, and we are seeing F53B PFAS.
Hmm.
We don't know why. We have quite a lot of concentration variations. So I don't think that's from the contamination. But we've been looking into why we were finding F53B in that old samples.
Okay. Well, it's very interesting. Again, thank you very much again for your presentation. We'll go ahead and move on if you'd like to stop.